Okay, so welcome everyone to tonight's Timber Development UK 2022 Design Competition webinar. To introduce myself, I'm Kirsty Connell-Skinner and I am the Sustainable Construction Partnerships Manager at Edinburgh Napier University, one of the university partners in the competition. For your information, our webinar tonight is being recorded. If you have any issues with that, please let Tabitha know. But this is obviously to help facilitate and make the learnings and the conversation tonight accessible to all the competition participants. So our topic tonight is engineering value, whole life cost. This is the second sort of learning webinar in the Timber Development UK competition series. You can find the first one online, and links to that and to the competition for any of you joining us for the first time will be posted in the chat during the evening. So just a general introduction, engineering value, how do we engineer value in timber building? For high quality, sustainable, resilient projects, there's a huge need for us to combine modern methods of construction, design for manufacturing and assembly, as well as finding that balance to ensure whole life performance and value is embedded across the whole project lifecycle, but it needs to be a critical success factor at the procurement stages, at the very earliest stages of our programme. And tonight we've got a fantastic selection of speakers who are going to take us through all of that to help you as sort of competition entrants and participants to really understand this really quite critical foundational processing that is needed to make sure we get best value out of our sustainable, resilient future timber buildings as you look to Hereford Southside and design your masterpieces. So I'm just going to do a very quick introduction and then hand over to the speakers. We're kicking off on modern methods of construction and design for manufacturing assembly with George Pleasence. George is a senior cost consultant at Consultancy. As I'm sure many of you know, CAST are at the real forefront of driving sustainable change in the development and construction industry. George is then followed by Alex Abbey and Carol Costello, who are partner and practice leader respectively at Cullinan Studio. They'll be speaking on procuring timber buildings and bringing their expertise in redefining a sort of common purpose towards the care of our planet through responsible design. Very exciting and really interesting stuff in terms of procuring timber buildings. That's then followed by the benefits of IPI and alliancing with Louise Lado-Byrnes, who's a director of IPI, which stands for Integrated Project Insurance. Really exciting, innovative new way, uniquely removing the barriers of that adversarial blame culture that we find all too often in construction and replacing those sort of hierarchical contracts with what's a truly collaborative flat contract. Really looking forward to hearing from Louise. And then last but by no means least, I'm going to get back into the real world with a collaborative framework casework study from the Edinburgh Homes Demonstrator. I'm talking to you tonight from Leith, which, if those of you who don't know Edinburgh, Edinburgh has a seaside and we're on it. And the Edinburgh Homes Demonstrator is just about a mile to my west in Granton. Really brilliant project. Just got sort of through the first round of planning for some great buildings to go up there in affordable housing. We'll be led through that by Nicola Jackson, who's technical manager at Robertson Construction and also part of Offsite Solutions Scotland. So we're obviously quite tight for time. We're all busy people. I'm sure we all have got other things, to catch up on at 8 o'clock. I'm certainly wanting to make sure I can see The Apprentice at 9 o'clock because I love looking at idiots on screens, which is why I work in academia and during the pandemic. So just a gentle reminder to our speakers to please keep to time. If those of you who aren't speaking can keep your microphones muted and your videos off just to help with the buffering and so we don't lose anyone or get frozen. And if you have any questions, there is a chat function, please post them in there. We'll either try and bring them up to the speakers or we'll address them with you afterwards. And I think Tabitha, you'll hang around for a bit as well, just in case anyone's got any questions about the competition specifically as well, sort of that sort of side of things. So without further ado, George, can I ask you to take the digital floor?
Yes, of course. Thank you very much for that, Kirsty. Let me just share screens here. We did test this, so hopefully it should all be working. Can you see that screen okay? And then I'll just put it in full screen.
Yep, that looks great, George.
Perfect. So as mentioned, I'm from CAST. We have been very much involved in modern methods of construction for some time now, and in particular, we saw a sort of need in the market that a lot of great innovative ways of constructing buildings, whether that be full sort of off-site manufacturing or near-site manufacturing, or just clever ways in which traditional led construction methodologies are being tweaked and improved. But there wasn't a sort of unified classing system for all of this, and sort of trying to give a bit more definition to what modern methods of construction actually is. So one of the first things that CAST really sort of set our stall out in to say we want to be involved in MMC and make sure we're at the forefront of modern methods of construction was to help define what those categories should look like. So we sort of put together the MMC category definition framework, and within that framework we established 7 key MMC categories. And you'll wonder why there's 8 squares there. That one's traditional. The rest of them are all the MMC categories. So I just wanted to give a bit of an overview about some of the language and sort of vernacular that gets used around these MMC categories, and then give some case studies as well, just as you can see them in practice, as well as just talk about why sort of improving levels of modern method of construction, and in corresponds with that as well, pre-manufactured value, which is something I'll get onto as well, just how those two things sort of interact with each other and how they hopefully have positive impacts on outcomes of construction projects. So category 1 is pre-manufactured 3D primary structural systems. I appreciate that that is very much a mouthful of a definition there, but this is probably the one that most people associate when they're thinking modern methods of construction. This is your volumetric solution. So this is the sort of full module. So it's coming with walls, coming with roofs, sort of the box whole system piece that's basically massively done on site, delivered to site, very little on-site sort of requirements to it to get it into a position where it is a sort of whole fabrication of the piece. And within each of these categories, there's obviously sort of bookends to each of these as well in terms of a fully volumetric, including fit out, podded bathrooms, podded kitchens, for example, and versions that just have the sort of structural chassis only. So we can do sort of levels of the box in which we then attach facade elements to, window elements to, and don't have the full fit out to them. So there's a whole range within that sort of category, but category 1 is basically your volumetric module solution. Category 2, which is one very much in particular with timber construction, it's pre-manufactured 2D primary structural systems. So in that Cat 1, essentially, that's your 3D volumetric solution. The Cat 2 is basically elements of a category 1 that when combined together can form a category 1 volumetric solution. And I think it's just a point worth saying in that we're not suggesting that MMC needs to always be at the top end. Your category 1's your best MMC, therefore it's the best solution for a project. Every project has its own desires, wants, needs, and complexities that require varying solutions of MMC. And what this is sort of about is just understanding what ways in which can we just improve upon the baseline of that of a traditional construction methodology. Can we introduce some of these categories? And that's where we sort of get to with some of these further down categories. But category 2 can be anything from basic framing, so simply just the actual frame itself, but brought in basically a sort of kit of parts, but still not just individual parts, but sort of 2D systems, a bit similar to the roof truss sort of iconography we've got to the side. And again, there's bookends to that in that you could also attach cladding to it, insulation to it, linings, and start to have that still category 2, but with sort of consolidated finishes to it as well. We then move into category 3. So a bit similar to how category 1 can basically be formed from a series of category 2s put together. A category 2 is basically a series of category 3s put together. So you see here that there are elements such as columns, shear walls, beams. Columns don't always have to be in situ concrete poured on a slab with formwork around them. They can be pre-manufactured. So there's that element of it's not a complete system in that it's not a modular solution or it's not an entire wall system. It's part of a bigger system, but there are still elements of category 3 that can very much enhance your level of modern method of construction that you could be looking at to incorporate into a building. you'll see some things on there as well in terms of that are just becoming quite common practice as well. So they're no longer sort of modern methods of construction. They're slowly starting to become the sort of usual way of working, which is brilliant. The fact that it was modern method and that they're becoming so oftenly used that they're no longer seen as the futuristic way of working is definitely something to be sort of proud of in the industry. I mean, staircases, for example, particularly when we're doing 2-story housing, 3-story housing, the amount of times that that staircase is actually cut and made on site is becoming less and less frequent. There are those staircases becoming more pre-manufactured and more manufactured on off-site solutions and brought into the construction site itself. Category 4 is a bit of a strange category, and it's probably the one that there's the least evidence about. It's additive manufacturing. So we've probably all seen videos on Facebook, YouTube, flicking through of a 3D printer, basically pouring concrete out around and around and around and building a sort of igloo structure. And that is something that is plausible. There's been a lot of testing around it, but for it to be rolled out in mass scale, it's not something, particularly in the UK, that we've seen huge examples of at the moment. So there is a category for it, and it's category 4, but this is one where there's probably the least practical case studies, but probably the largest potential for growth and within that category, because there'll start to be elements around 3D printing and all of these other additives that can be put into buildings on a sort of mechanical based construction methodology whilst on site and just being done sort of in situ but in a modern way. So there's going to be a lot of exciting things I think to come through this particular category, but at this moment in time it's probably the one we know the least about. Category 5, you'll see there's a lot of subcategories there, and I think sometimes people they see a building going up and they're working on a project and they think actually that's not, we're doing bits and pieces, but some of these combinations of these category 5s, although individually they may seem small in comparison to that of a volumetric solution where you're doing everything basically off-site and just delivering the whole unit to your construction site, combinations of these category 5s can quickly become a relatively modern method way of constructing a building. Take, for example, some of these first 3, 5A, 5B, and 5C, particularly on student units, anything basically with a dense floor plate where there's a lot of bathrooms across the floor slab. Doing that traditionally is just becoming less and less of a sort of occurrence. And it's starting to become more and more of the norm. So whenever I say the word sort of podded, it's basically a volumetric solution, but for an element of the building. So it's basically a bathroom module, but we call it a pod because it's not as big as a module. So we have podded solutions, and they're becoming much more frequent, and particularly on dense floor plate constructions. So you see bathroom assemblies, kitchen assemblies, and even working with some manufacturers who do combined bathroom and kitchen assemblies as well. If you think about what the unit in a residential building looks like, if you were to actually have your bathroom and your kitchen produced off site and brought into the construction site, that's a big element of your work that's actually being done under a factory setting. And it's the same with the M&E potential there as well. A lot of times now the vertical risers and the utility cupboards, they can be done in factories and sort of brought onto site as well. So there's no need to have these wet trades on site as frequently and all of these coordination of sort of service distributions as well. There are elements of MMC that can be done to sort of aid with trying to speed these up and start to become more modern methods of construction around these. We then move into category 6, which is traditional building product-led site labour reduction. So again, it doesn't necessarily mean that everything needs to be done in the factory. In fact, moving everything under a factory roof, but if it was to be done still in a traditional way, but just doing it under a factory roof, isn't actually really a modern method of construction. It's just doing what you do on site, but with the added overhead of a factory warehouse. So with all of those things in mind, it can still be done site-led improvements on site, that the way in which you cut some products, the way in which you finish roofing finishes, for example, does it have to be mass individual tiles, or can we get sections of these sort of predetermined? Can we have traditional materials that aren't just turning up in their most raw constituent parts, but we can actually start to cleverly cut them and piece them so that when it actually comes to going on site, it's a lot easier to actually install them, joint them, and interface between these traditional independent pieces. And the last category is out of category 7, which there are some really interesting pieces around you. And again, probably seen videos on some of this, but site worker augmentation, whether that be visual in terms of VAR headsets to try and understand BIM models before actually constructing on site, whether you can have something physical like exoskeletons to help in the aid of in carrying things from floor to floor, transporting in heavy materials, using extensions to help build a brickwork without having to use scaffolding or whatever it may be. There's a lot of emphasis in the construction industry at the moment on the way in which preliminaries can help to produce more modern methods of construction. So there's lots of potential in this place. And you see use of BIM. BIM is very much used in design practice, but in terms of actually getting it to site, sometimes you'll be on a site, you've got a BIM model, but someone's just printed every DWG attached to that and just still has it in their rack of drawings. So the actual physical using of a BIM model to actually build the project in which you're on is something that still just needs a bit of enticing out, but a lot of interesting spaces within category 7 and expansion in which can happen in this category. So I mentioned the word PMV, and PMV stands for pre-manufactured value. So we understood at CAST that there's a lots of talk around modern methods of construction. They'll do X, Y, Z in terms of cost, predictability, health and safety, carbon, all of these key metrics. But there was no way to sort of quantify, which is something that has traditionally been quite a qualitative description of how to improve construction methodologies. So we sort of established pre-manufactured value and came up with the sort of formulas and way in which you can calculate these. And depending on what sort of bookend you're at with the MMC category in which you're trying to adopt, will improve or increase your PMV value. So you can see we range from anything from sort of 80% pre-manufactured value in the modular solution, that category 1, down to sort of 45% where you're fairly traditional, but just doing some site-led improvements to things. And I guess without just putting a score to something, you need to understand, why are we trying to put that score to it? Why do we want to see increases in PMV? And why do we want to see increases in modern methods of construction? Because the more that's done in a sort of factory setting, or at least a modern method of construction, your predictability of outcomes should be greater. You're doing these things in a continuous workflow and not sort of adverse risk to in situ problems that can come up when their things are just done traditionally. Productivity improvements and waste reduction, all of these things, if they've been cleverly designed, they've been manufactured in a way in which allows for minimal waste reduction as well. That's only going to increase productivity, and it's only going to decrease waste. So all of these modern methods of construction are aimed at trying to increase in both of these. Quality and performance, again, something that's under a factory setting, well designed, modern method and way it's been constructed, it just sort of negates that risk of more traditionally led in situ construction methodologies potentially lacking in quality and performance. On-site delivery speed and site overhead, so your actual how long you're going to be on site is going to be a lot quicker if all of the bulk of the work is being done under a modular factory setting off site and then brought to site, which means less time being spent on site, less disruption being caused to surrounding buildings and project sites and all of that. So less time on site with higher levels of MMC. And transactional costs. It's a difficult one, transactional costs, in that sometimes paying for modular methods, modular construction in particular, and some of the other high categories can look like at inception it's going to cost more money. But the sort of purpose of what we put transactional costs in there for is it's not just about the number that you get at the beginning, it's about the number you get at the end. If you're in a traditionally led construction methodology project where everything's being built traditionally, you sign up to one number. all manner of things can happen between those various amounts of packages and interfaces and wet trades, and all of that can happen, which means that your starting number is no longer where you're actually ending up. The idea of being able to move a lot of that under a factory setting, modern methods of construction means that hopefully your starting number and your end number are nowhere near as far away from each other than that of what we would expect to see on a traditional project. Community disruption as well is something that, you know, we all need to be considerate of what we're building these buildings, where these things are going. There's going to be surrounding neighborhoods, people. We need to ensure that what we're doing has a positive impact. By being on site for a less amount of time, we can help to reduce the community disruption that could be caused. And site health and safety risk. Again, if you're on site for less time, less opportunity to have accidents, and if there's less amount of trade packages working amongst one another, there's a less coordination risk. So therefore, hopefully, there'll be less health and safety, greater levels of health and safety and less accidents. And I was just asked in particular to just put together a little time frame in terms of how do these modern methods of construction interact with the RIBA design stages. And you can see all of these MMC categories, really, the earlier that they're sort of adopted and a decision is made, the better these things are going to be implemented, and the design team is going to be able to go ahead and actually design with this modern method of construction intent in mind and always there. It's very difficult, particularly with your Cat 1s and 2s, to get to a RIBA stage 3 and then say, actually, what if we did this in a volumetric solution? It's very difficult to bring that back in. But starting at RIBA stage 0 to 1 and saying, you know, we're going to go ahead with this as a volumetric solution, that design will only be sort of felt off good principles in terms of levels of repetition, the stackability of things. So having that mindset of, I'm going to deliver this as a Cat 1, an early RIBA stage, is only a good incentive, because if you make the decision at a later stage of design stages that actually we're not going to do this modular, we're going to do it traditional, that is still a traditional design that's been sort of founded off of good practices and good sort of design ideologies. There's no reason why that can't continue and just be traditional, but trying to do it the other way around is very difficult. And I've all just put in a couple of projects here as well, just to give you a bit of a flavour of how big and scale some of these can be. I mean, people think sort of volumetric modules, sometimes it's just related to houses, or it's just a couple of quirky little office buildings that are out there, but they are starting to get very big in scale, with the sort of traditional built core in the center being able to wrap modern methods of construction around. These are all volumetric pods basically going in. So this is down in Croydon, this is with Greystar, and it's a 40-story tower. Now this 40-story tower is able to be constructed in 18 months. And if anyone's worked on or read up about tower construction being done not in a volumetric solution, they'll understand how quickly 18 months to deliver 40 stories really is. This thing really did shoot up. The time lapse for it is exceptionally short. So the on-site time that was there for it being a volumetric solution was vastly smaller than if it was to be done traditionally. Cat 2 as well, just got N06 East Village. Again, this was two 30-story towers. So again, still big in scale, and the time period in which this was able to be done in as well, compared to a traditional construction, was significant. So yeah, that's some category 2s. And category 5s, bathroom pods and kitchen pods. So we use these on one of our projects called N08, which is down in Reading, 482 units. So you can imagine 482 bathrooms having to be done traditionally means the tiler needs to go in there 482 times. Person who's putting the actual bath in, the shower cubicles in, putting the actual trays in, all of the plumbers that are going into it, anyone who's then going in to put all the mirrors to vanity units in, doing that 482 times with that amount of combination of different trades not being able to go in at different times and having stand down periods whilst things are drying. Having that under a pre-manufactured solution just massively increased the speed of the program. And then Temple Quarter is another one in where we've had some category 6 facade treatments. So it was a relatively traditional built shell and core and frame to it and all, but the actual facade, that brick system actually sits on top of sort of intersecting poles that go across. So it's basically just being able to slot them straight on to the facade. So it was able to really speed up the actual installation of the brickwork, and it also lowered the amount of hiring that we had to do of access to get this brickwork there if we was to compare it to that of a traditional solution. And that was basically it. There was an overview of the MMC framework that we have, a bit of an insight into pre-manufactured value, and just a couple of case studies as so you can see how these things actually work in real life practice. So in trying to keep it short and sweet, Kirsty, I think that's it from me.
Thank you so much, George. You're perfectly on time. Love it. And love the combination of both the theory and the knowledge and the detail, but then the real life examples. That's absolutely brilliant. Unfortunately, Alex Abbey is unable to join us, but I'd love to invite Carol Costello to come in now and talk us through procuring timber buildings. Carol, over to you.
Okay, yeah, thanks. Yes, apologies from my colleague Alex. We have a presentation which he was going to present, but I can do that, but bear with me a bit if it's not as smooth as we would have hoped. Let me just, sorry about this. Can everyone see that?
Yep, can see that.
Great. Okay, I'll just jump in. So I'm Carol Costello, and I'm an architect and practice leader at Cullinan Studio. And I used to be the former chair of the TRADA advisory board. And my colleague, Alex Abbey, is now the chair of TDC advisory board. And he's our education sector lead as well. So our practice is really all about collaboration. We were set up over 50 years ago by Ted Cullinan as a employee-owned cooperative, and we still operate on those grounds today. And it served us well over the years. And we have a reputation for an ethical approach and a sustainable approach to the environment and to people. And we still see that as the strong theme running through our practice in terms of engaging with people and empowering them to shape their cities, but also empowering them to make good environments for themselves and for nature. So when we think about timber's role in all that, again, the practice has a long reputation of working creatively with timber, and we love it. It's a fantastic material to work with. And it's at a really interesting point in how we use it, because we know it's easy to build with, quick to build with, it has very low embodied carbon. And we really need to use these kind of low embodied carbon materials if we're going to tackle the climate challenge and new targets to meet net zero. And the evidence is really overwhelming that the loss of nature in our world is harming us and harming the planet. Trees have a huge role to play in that. So planting trees is important, but also thinking of using trees as a source of construction is a very sustainable approach as well. And we know that we spend a lot of time indoors, and that actually buildings made from timber can be much, much healthier for us and work very well with passive house design principles. And the use of timber on interiors of buildings, there's evidence now that that actually helps recovery in hospital situations and productivity in the workplace. We're signed up to the RIBA 2030 Climate Change Challenge. So that means we are measuring embodied carbon and operational carbon on all our projects, regardless of whether our client has included that as part of the brief, and that's how we're going to learn. And I would just say that projects we were working on before we signed up to the challenge, where there were no targets really for embodied carbon, we are measuring those, but we can see on recent projects where we're measuring, even if it's not part of the brief, we're actually making more inroads to reducing the embodied carbon of that. And that's partly through the use of timber. So TRADA has produced advice about how you procure engineered timber buildings. For students out there, you might not realize the hurdles that you would face in specifying a timber building, but you will face them. And I'll talk a bit about that in this presentation. Alex has included quite a fun slide here about timber. I think he's really just included this because there's such versatility in the use of timber and the forms it can take in both sheet material and linings, but also in terms of structural elements, all the way to structural beams and cross-laminated timber decking. But timber's been around for a long time, probably since the dawn of time. We've been building with timber, and we know timber buildings have lasted a long time. These stave churches in Russia and Norway are, some of them are 500 years old, and we have very old examples as well in this country. And the engineering of timber has led to some fantastic architecture, which I hope the students can take inspiration from. But it's also been used in very workmanlike industrial buildings as well, and then development of engineering and truss structures is very common in our historical buildings. And this was an example of using lots of small elements of timbers to make airship hangars at the start of the 20th century. And we ourselves have worked on projects where we've used small sections of timber very efficiently to create grid shell structure. And this is just a slide of that grid shell structure at the Wilden Downland Museum under construction, where it's a lattice of oak lathes with scarf joints. And those were then lowered into this sort of peanut shape to give it its strength. And that's the finished building, and that's the interior of the building. If you can ever get a chance to go down to the Wilden Downland Museum, I highly recommend it, not just for this building, but for all their buildings. And if any of you watch that television show, The Repair Shop, it's filmed at Wilden Downland Museum. So that's a great place for any architecture student to go to learn about the history of timber construction and timber craftsmanship. Just a bit on cost. This photo on the right is our visitor center at the Royal Botanic Gardens in Edinburgh, which has glulam beams with a cross-laminated deck for the roof. Actually, all kind of fabricated offsite and then brought in and constructed quite quickly as a kit of parts. And you know, the architecture is expressed through the exposing the timber structure. So there's not a need for lots of different linings to cover up and try and make the interiors look good through that. The actual design of the architecture and the structure is the architecture of the building. But we come into conflict on projects in terms of a lot of contractors don't work with these kind of special timber structures. It's not a conventional choice, and you will quite often be faced with many people along the journey of a project who will say, why can't we make the building out of something else? And they might, at the start of a project, talk about potentially higher capital costs for timber structures. but that can be mitigated by the speed and some of the offsite fabrication that can save time on site and negate those upfront costs. I think the other barrier you will come across is insurance, and TRADA has been working for years with the insurance company and the supply chain to address some of these issues and also provide better guidance for specifiers and contractors in terms of how you build with timber to protect it from fire and from moisture. So, you know, it's just something that we who are passionate about timber still need to address. And, you know, every material has its pros and cons. And it's great that the Structural Timber Association has created more guidance, the 16 steps to fire safety for timber frame construction. Regarding how fast you can build with it, about 10 years ago, at that time, the new conservative government laid down a challenge to build new schools for £1,200 per square meter. So we started working with Stuart Mill to see if we could do a flat pack school made from timber. And we came up with this kind of generic idea for a 2-form entry primary school made with SIPS panels that could be constructed quickly and for a really low budget. And then we finally got a commission and we had this flat pack school ready to go. And we built the Holy Cross School in Swindon using SIPS panels with Stuart Mill. And it did go up fast. It wasn't £1,200 a square meter, but it was close to £1,400 a square meter for the build, which is incredibly cheap. So, so that's a design we could apply elsewhere as well in a modular way. But we can do a lot more sophisticated things with timber. We finished the National Automotive Innovation Center a few years ago at the University of Warwick, which houses research engineers from Jaguar Land Rover and Tata Motors, along with the Warwick Manufacturing Group. And this has one of the largest glulam and CLT roofs in Europe. I'm not sure about the world, but it's a kind of real tour de force of engineering, and it looks amazing. And for Jaguar Land Rover and Tata Motors, it was kind of a leap of faith to go with a timber building. They didn't see that as particularly harmonious with the automotive's aesthetic, but then they realized what they're researching in this building is all about the future of mobility, and that needs to be green. And they see the kind of sustainability of the architecture of this building as symbolic of their mission to create more sustainable transport and mobility. So it's been a real success. So it is true that a lot of our timber supply comes from Europe. And so there are issues with pricing from that. And I think that's probably going to be the case for a while. I don't think the forestry in this country can supply anywhere near the quantities that we get and from Europe. But I think, you know, we would all like to promote the companies here that do produce timber structural elements. And Alex has put in a great slide from Switzerland of being able to install these lightweight timber elements by helicopter. Bit about planning. I think one of the advantages of timber in terms of build is you can it can give you a lot of advantages in terms of disruption, noise, speed on a building site. So, you know, if it's built off, a lot of it's built off site, it can be brought in quite cleanly and assemble cleanly on site. So there's advantages there. This is our project for the Royal Horticultural Society at their gardens in Essex called Hyde Hall. I definitely recommend a visit if you live in that part of the country. The gardens are absolutely beautiful. But timber was a great choice for them because they needed to build quickly in between visitor seasons, really, to get these buildings up. And they've got a great ambiance. And for the Royal Horticultural Society, which is all about plants and nature, building out of timber was, you know, a no-brainer. That's they wanted to use something from the plant kingdom to make their buildings out of. And then there's a home that we did in the Chilterns, which is a lovely private home, but it's all CLT structure, and it gives the interior of this house a great feeling of warmth and craftsmanship. And we applied a sort of white wood wax to this timber to keep it light and airy. So just a few slides on wellness and circular economy. This is a slide from Hawkins Brown. I mean, we're all having to think about what happens to materials at the end of their life. You can't just throw things away. There is no away. Things come back to us as we see all the plastic rubbish washing up on our shores again once we think we've thrown it away. So when we're constructing buildings, we need to think about how we would deconstruct them. And timber is probably one of the easiest systems for thinking about deconstruction at end of life. We have a project at the moment for the Bankside Open Spaces Trust in Southwark and London, and the brief there is for a circular economy approach. So we are actually working with suppliers of reclaimed materials so that the entire structure will be made from reclaimed steel and reclaimed timber. And some of the timber is quite old because the company we work with specializes in reclaiming old piles from the river. So some of these are hundreds of years old, these beams, and very durable timbers, tropical timbers that were used, say, up to 200, 300 years ago as piles in the river. So it's really fascinating to research that source of material and to think about how the architecture works when you're using reclaimed materials. Generally, the spans need to be shorter because that gives you access to a lot more reclaimed material. The longer the spans, the more you narrow your choice of reclaimed materials. I think touched on air quality, but there's definitely research that's been done to prove that using timber indoors with the right coatings and treatments improves the air quality in internal spaces. And interesting research about workplace productivity, where they found in one study that the workers in the rooms that had more timber lining and furniture were a bit happier and more productive. We've just about to finish a new mental health unit at Alderhay Children's Hospital in Liverpool, and this is all made out of CLT timber as well. So we'll be really excited when that's finished and we can show you the interiors of that. But during the briefing of this with the mental health experts, they were really keen that we provided a calm and healing environment, and timber is a a really good choice to create this type of building. I'm just going to finish off quickly with a few slides that, these are the slides I was meant to present only after Alex's presentation, but I see this as a segue between the previous slides and our next speaker, which is Louise Lado-Byrnes, who I worked with on a project which used an IPI contract, and IPI means Integrated Project Insurance. And that project was Black Country and Marches Institute of Technology, which we just finished very successfully in August this year. And I just wanted to share a few lessons from this project. The project is a naturally ventilated building. And the thing about integrated project insurance is we were working with the contractor and the client from the beginning before we even drew anything. And because and Louise will explain more about the type of contract, but basically we formed an alliance where we were sharing risk together and making decisions together. So these are some slides of everybody in an optioneering workshop about the structure of the building, where we looked at options for steel, concrete, and timber frame together. In the end, we did not select a timber frame. And part of that was because of the client and the contractor who'd worked together had delivered a really successful project which used a steel frame and concrete deck and a thermally active building system that was performing really well. And the cost of timber was a bit higher. So we had to make those decisions together as a team. And on balance, in this case, we decided to go for that same steel and concrete and thermally active building system for the project. We also had the opportunity to think about timber cassettes for the wall, a sort of SIPS panel system. And we engaged with some really fantastic suppliers of that. But the barrier for using that really was to do with the final building insurance, because the timber SIPS panel manufacturer couldn't meet the high rating for combustibility that the building insurer Zurich required. So that sort of put a stop to that on this project. But the whole team kind of realizes this is a great way to deliver buildings. It's been delivered on time and on budget and with no claims. And the client is super happy with it. So we also think it could be a great way to deliver low embodied carbon and net zero projects, if that's apologies, that was my cat. Can you still hear me? So it is a great way, we think, to deliver sustainable architecture. And I'm going to hand over to Louise.
Brilliant. Thanks so much, Carol. Just to, say some of those examples, particularly, Holy Cross is an educational space, Bankside, John Hope Gateway, and of course the Royal Horticultural Society. Absolutely fantastic exemplars for our students looking at the Hereford Southside brief. So thank you so much for sharing them. Louise, please take it away.
I'm doing my best. It won't go on to the right mode at the moment. Right, so I'm going to stop sharing and reshare that with. Sorry, technical failure already. When I share, it's not doing what it's supposed to do. Right, there we go. Can everyone hear me okay? Right, so Carol's already touched on that. So I'm not here to really talk much about structural timber, but what I recognise in what George said and what Carol said is that the possibility of achieving what we need is very difficult with the current setup. So out in the industry, well, since 1994-96, and I know a lot of you are quite young listening to me today, there have been reports in our industry. We're very good at producing reports, and obviously George's colleague Mark Farmer, the Farm Review, is talking about modernise or die. We've got infrastructure, the Construction Leadership Council are telling us to procure for value, and so on. And more latterly, we have the Construction Playbook, which sets out a set of rules and targets that the government wants to achieve. And then very recently, at the end of last year, we had David Melzi sort of talking about constructing the gold standards. Now, why am I here and what's the difference? So one of the things you've got to appreciate is how the industry currently works. And you heard George talk about the fact that, you know, you can only get to our IBA stage 3 or 4, then you go out to tender, and then you get a tender back, and then you're in the realms of impossibility of looking at other solutions like structural timber solutions. And at the beginning of any project, when the client has the idea in their head, when they're at this briefing stage, there's an ability and a cost to change. And if you have a blank sheet of paper, the ability to change is vast, and the cost to change as you go further through the project goes up and the ability goes down. So everyone you hear, lots of you will hear about early contractor involvement and earliest involvement and so on and so forth. So why doesn't that happen? We all hear this thing called design and build, and I'm an ex-contractor. I've spent 20 years contracting and probably have spent the equivalent amount of time now in consulting, in collaboration and integration. So what everyone says is what we actually need is the delivery team to talk to the design team and actually move, so they're both before that curve. But they've never been able to do that. So our concept at IPI was to look at why that happens and actually try and design a solution and intersolution out of that. So some of the things that stop us, and you've heard a couple of mentions of insurance, are the contracts themselves. So on one hand, we have up front, we have the service contracts and the insurances under PI, and we have all the designers brought to the client with some sort of employer's agent and cost manager for the client working away. And then they go out to tender, probably get up to our IBA stage 3 or 4, sort of where they're getting close to the detailed design and more, and they go out to tender to design and build. Then you go into a separate set of insurances, which are all about contractor delivery. And as you can see, it's a bit like the car crash mentality. If something goes wrong on a project, if you're using a JCT design and build or an NEC design and build contract, when something goes wrong, people tend to step out. It's like when you have a car crash and you say, you get out of the car and say, the insurers will deal with it, we don't want to know. And on construction sites historically and going forward, actually we lose resource off site. When we get into that claims mentality, we lose resource. So what we said was, well, how do we overcome that? Well, let's get rid of those insurances. Let's get rid of those barriers and blockers. And let's actually do this so we can deliver, look at delivery teams and design teams. And you saw Carol's photos and heard Carol say, they're all in up front. So how do we do that? We do that because we have a specific contract that we've designed to work with a specific insurance. Now, whilst we derive our name, Integrated Project Insurance, from that product, the whole package is a model of delivery. So we procure a particular way and we deliver a particular way. So we are able to do that because we've got to get rid of this fragmentation in the industry. And we've got to, I as an ex-contractor, I have to tell you, we didn't call it design and build, we called it design and dump. Because what also happens is you get this strange phenomenon where the client will go out to tender, get the main contractor on board, and all of the risk sits with that one person. So of course they're going to cover their back. Of course they're going to look to pass risk down the supply chain. And the other thing that happens, and Carol will bear this out, is quite often the architectural and the design teams are novated across to the construction teams. And the margins are low, and the understanding of value and the disconnect between CapEx and what we're talking about, sustainability and life cycle, is really sort of not really thought through. So if you look at Japan, they spend 2/3 of their budget planning and 1/3 of their budget and time doing. So whilst offsite costs more, the reduced time still produces the right sort of solution. So if I put everyone in a darkened room, and when we do ask people in the industry what they would change, if those of us who are stalwarts of the industry, if you were in a darkened room, what would you change? And these are actually, I'm not going to read through all these, but these are the sort of things that we always get to see. And then we'll run a training course and we'll say, right, now from what you understand about what the IPI model, or it's coined a phrase of insurance-backed alliancing, which is a much better description. This is what people want. There's a lot of this lowest price wins, race to the bottom, skill shortage. We talked about that, so that's where Offsite comes in. Open and honest dialogue, less confrontational behaviour, capturing the need, understanding the client better. Sometimes it's a bit like Chinese whispers. I don't know if you know the old World One adage of the front line going, send reinforcements, we're going to advance, and it gets all the way back to base and it says, send 3 and 4 pence, we're going to advance. Well, that's kind of how I see the construction industry. So the client need right up front is not part of what the suppliers and the specialists see. So what we did with the IPI model is we said, right, how can we solve that? So everyone, including designers, constructors, specialists alike, sign into one multi-party contract, an alliance contract, which is written by us, known by us at the moment. We invite the whole supply chain to the party, and everyone talks about that, but it's so difficult to do if you go back to my curves of when the whole supply chain's in, they're always in after that curve goes more to change and less possibility of changing. We run each project as a virtual business with a board of experts. So if you imagine it literally as a business, we have various departments, architectural, MEP design, MEP delivery, construction delivery, and various trades and specialists, roofers, cladders, etc., steel frames. So we run it with a board of experts. And importantly, and one of the things many people would like to change about the industry is how we pay for things. The fact that we go through this third party, and those of you know the history of the Carillons and others of this world that have sort of disappeared overnight because all they did was play with people's money and keep hold of people's money. So we want to put the funding for a project into a project bank account or a trust account, and we want to pay everyone at the same time for what they do. Here's a biggie, and this is why it links into what both George and Carol have said. We don't start the design until the fundamentals of the solution are agreed. Now, one of the issues Carol's mentioned was insurance. So we have within the contract, we have independent experts as part of the process, checking and doing due diligence on the solutions we arrive at. We have all of the team inputting from day one. And importantly, we don't do cost at all. If you think about it on an IPI project, there is no design when we procure the team. So how do we procure that team? Well, we check their ability, we check that they can actually do what we want them to do in terms of their department, if you like, within the virtual business. And we procure them based on their ability to integrate, collaborate, not blame people, and have good behaviours. And you've heard from Carol that that's what her whole practice is based on. So hence, Cullinan, we're on our last job. A big one I heard also, George mentioned about BIM. Every IPI project so far has had massive BIM and digital twin input, and we can do that for lots of reasons, which I'll explain. So importantly, so how do we make sure the client gets their desired outcome? And I looked up figures before I did my training in December, and as an industry, we are still working at something like 30 to 40% over cost and time on most of our traditionally procured projects. And that's not great for the industry. Don't get me wrong, there are some really good projects out there, and there's some frameworks that are trying to address this in a different way. But actually, if you've got sustainability and net zero at the heart of what you want to achieve as a client, then we as IPI can do this a lot better than traditional projects. And the reason we can do it is because of the way we set the project up. So you've heard we procure everyone at once. They all sign the same contract. There is no right to subrogation in that contract, i.e. you can't put a claim in, you can't blame anyone, and we insure it differently. So You have this project team alignment. You sign the alliance contract at day one. Once you've procured that team, they sign the alliance contract. It's a live contract. And we align the team both culturally and commercially. And the board of directors agree that they can build that building and that module in that time for that amount of money. And then we have the insurance product. So we have 3 independent experts in the process. They are there to, so if you imagine that this is completely new to most people, it's quite radical, and people don't understand how to change behaviour. They need someone constantly to remind them. And we've built in an independent facilitator who's there to actually ensure those values and behaviours are maintained. And they, once we get to a particular part of the project, they adhere to the client, if you like. We then have some good acronyms in IPI. We have a TRADA and a FIRA, which are technical and financial risk assurers. Now, they are there to do a due diligence role, and they report back to the insurers. So because they are there, and because the independent facilitator is there, and because we're procuring from a top-down value, we are able to get a different type of insurance. So we thought quite carefully, and we said, well, how do we do that? You know, PI is a massive area of problem at the moment. So if you see where I've got cost over in there, normally you would see professional indemnity insurance sitting in that. So what we did was we said, if we just change the way we think, and rather than insuring the inputs and therefore be worried about the design, what happens if we insure outputs? So what we did was we put constructional risk, third-party latent defects, which I'll come on to, and a cost overrun insurance in. And what we then do is we insure everyone who works on that project, the client, the constructors, the specialists, the designers, everyone alike. And what this does immediately is it means that everyone owns everything. So it's not just Carol's design or George's construct, it is everyone's design and construct, and everyone owns the cost. Now, when you're looking at putting solutions in that insurers are wary of and clients think are too expensive, I think the only way to do that is to do it right up front when the client has their very first idea. So this is how it might look, and what the focus is on the project need. And we'll have that board of directors, constructor, FM designer. We can have all sorts of people actually sitting in that circle, and the supply chain can come in at varying points. We have project bank accounts, we have the alliance contract. We use BIM and a digital platform from day one. And one of the reasons that's easier on an IPI project is you don't have to worry about your PI, and therefore you can share all your information and all your ideas up front. There is a lot of reticence to do that on major projects elsewhere. So why does this actually matter? Why have we turned the industry upside down? And more importantly, we're often asked why clients aren't taking up IPI much more than they are. I think we've got forced behaviours in the industry put in place by the current processes. And old Einstein, if you always do what you always did, you always get what you always got. So we're restrained in our thinking, and we're much too late getting that whole team involvement on the project. But specifically, when control of risk, cost and innovation is completely curtailed by that design and construct separation, those different contracts and those different insurances. So the IPI, and I wrote down when George was mentioning about using Offsite and how you get to our IBA stages. Carol also indicated that we tried to do some SIPS panels and some Offsite type of work with the last project we delivered and didn't quite get there. So when you look at how IPI works with the various phases, so we'll go through the procurement, then we've got the appointments, then we've got this commercial and cultural alignment. And phase one is all about looking at solutions and actually seeing what works and what doesn't. And Carol had some much better photos than me, incidentally, Carol. Photos of how we did that, how we do optioneering workshops. The other thing we do straight away, because we're in BIM, because we're in model and digital twin, we're also able to try and test things with a digital coordinator across the team. We also have what we call build in a day workshops, which is 4D modeling, which is the model being built alongside the construction program. We have all the suppliers in the room, and they actually examine and see what's different, what we could do differently. Why is it paused for 5 minutes? Oh, we've got a scaffold that's a cantilevered scaffold over the base. Well, why don't we leave that bit of the building down and have a normal scaffold or get a cherry picker in? There are lots of fantastic solutions. And commercially, what we do is we say, how much money has the client got to spend, and therefore how do we spend it? And one of the successes of IPI is that it actually makes sure that everyone has skin in the game from day one to completion. The latent defects policy on IPI projects is actually 12 years. And hence we will have some interesting debates about structural timber and timber solutions. And the insurance industry, interested to get George to take on this, they view it, they said to us a couple of years ago when we were talking with CAST actually, was, yeah, this repetition of unit, what happens if there's a defect in the unit? Then we've got it repeated 420 times. So we need to actually engage the insurers better. But if we do it this way, they're in it from day one. They can see that the solution is tried and tested. But more importantly, the whole team responds to the client's needs. So the client expresses their needs in a strategic brief. Now, if they put net zero and sustainability at the top there, they actually prioritize it, then the whole team from day one is focused on that. And you can see here, I've got a couple of slides from the first IPI project, and Carol explained that the client really liked that because it cost them 50% less to run than the adjacent building, which was for a very similar use. And actually the project we just put up with Carol, the IoT, has gone down a further 28%. So, you know, this is massive, even though we've not gone down the structural timber solution. So what's different about IPI, and why does it make it more possible to do what you're all talking about within structural timber? Selection and appointment is about getting everyone in together before the design's really truly complete and considered. That means that if the client puts the priority on sustainability and net zero, that is something that the team will have to focus on. The success criteria sort of clarifies and defines the outcomes. The integrated insurance means that because the same policy is covering everyone, we don't need professional indemnity insurance, and that's massive, particularly for designers. And it also just absolutely spirits out innovation in the team that's working on the project. The other thing that's very poorly thought about, testing, commissioning, digital, soft, I'll come back to digital, soft landings. We consider soft landings from day one. Not only that, we look at system operational interfaces. So the building is tested and handed over. We don't have any warrant, we don't have any bonds, we don't have any retentions, we don't have a practical completion. When we have that building tested, tried, systemly interface operational, and then we hand the building over to the client. We have within the Alliance contract, we have principles and values that people design together and agree to work to. This is Fusion, this came out of Glaxo, and you can see the acronym for yourself. This one, the STEAM principles, supportive teamwork, ethical, accountable, and makers, came out of the Museum of Making, which has just won awards all over the country. And that was a bit of a test for IPI. That was a grade 2 listed building, the first factory, working factory in the country in Derby. And that actually within the contract, the only way you can actually technically, let's use the term, be thrown off the contract is if you don't work to these values and behaviours. And each of them will be different because each team on each project will devise those together. So what outcomes have we had, and how does it relate back to what you are doing? So what happens in traditional when you get that throw over the wall sort of separation of design and construct is that the constructors, or the main contractors, as we're used to calling them under IPI, we call everyone constructors and suppliers. We actually don't want that main contractor to hold all the risk. We manage the risk together. I haven't had much opportunity to talk about that. We look at all of the issues in known industry failures is the title here. This isn't my slide. I've stolen this from one of my teams. But collaborative and integrated working has always since Latham Meath in 94, 96 been the way forward. But all of the reports talk about what they want delivered, but they don't talk about how we do it. And IPI actually does deliver. We've got evidence that we can tick off all the playbook, we can tick off the procuring for value, and depending on what the client wants, we can achieve what they want for the budget they've got. So we have finished all of our projects on time, even through COVID. And because if you go back to that ethical value in the Museum of Making, they managed to get extra funding for the COVID problem because it was the right thing to do. And actually the HLF are the only project they actually funded. So that's the silk mill on the River Derwent. Carol has shown you a more updated version of Dudley College. Sustainability targets were met. We set those together. So we originally had 2 buildings. The outline planning was for 2 buildings, and this is what we ended up with. But we used the building itself because we had all the team together. We looked at the efficacy of the acoustic solution. So that T along the road here at the back is actually part of the acoustic solution. We work on a best for project basis, and I won't go into it now, but we do fit for defined purpose. So when we have the client's brief, success criteria, we then work out as a team what those acceptance criteria for that is. We tick them off at the end, and hence we're able to say fit for defined purpose. The team is the biggest thing that's come out from all the feedback sessions we've run, is how adaptable and flexible it is to work on an IPI project. Because when there's an issue, because everyone owns the cost, everyone owns the risk, when there's an issue, everyone steps in. On traditional projects, everyone steps out. So we solve problems very, very quickly. These are just some of the comments that we've had from people who've worked on IPI projects. These are feedback sessions. We do them all the time. And you can see here, one of the things that came out for me that we weren't expecting is better mental health on our projects. They're collaborative, they're fun. People aren't going home worried about if they've written the right letter for the claim. So here we go, thought-provoking, inclusive, collaborative, engaging, fantastic. I could read them all. But you get the gist of it. And I think this hands nicely over to our next speaker. And I think one of the key skills that you need to collaborate and integrate and deliver the client's needs, be they net zero or whatever, is about integration. And I think one of the things I often say to people is that old adage of 2 ears, 1 mouth. When you're talking, you're just repeating what you already know. When you listen, you might learn something. So that's me. Thank you very much.
Absolutely brilliant. Thank you so much, Louise. Just before we move on to yourself, Nicola, I've noticed a couple of quick questions in the chat. So if we can just pick them up.
Yeah, I couldn't see those.
No worries. There's one for you, Louise, and there's one for Carol as well. Louise, I think you did actually sort of cover this just with the sort of final parts of your presentation, but maybe just worth reiterating. Joe Grant would want to ask, what about integrated project delivery, where obviously risk and cost of change is shared by all parties?
Integrated project delivery. I'm not quite sure I understand the question, if I'm being honest, but I think they're talking about the fact there's integrated project delivery, which actually started in America, didn't it?
Yeah, so I think it's just as an alternative.
Yeah,
approach.
I think it's very similar. The missing bits are the insurance, the procurement of the team on one contract, the no right to subrogation. So they're doing it. So it's a bit like when you get a really successful JCT or a really successful NEC, sometimes, and don't tell anyone I said this, but sometimes it's in spite of the contract instead of because of it.
Don't tell anyone you said that on a recorded webinar.
They've all heard it before. But
yeah.
So what we tried to do is put a whole process and contract in place that meant that was the norm. That didn't happen in spite of it, but because of the process and the contract. That's the best I can do there.
That's great, thank you. Joe, if you've got any follow-up, please do add it to the chat. And Carol, also from Joe, do you prefer a natural ventilation strategy over passive house?
Ooh. I don't think I prefer one over the other. It depends on the project and what you're trying to achieve. I mean, I think everybody likes the option to open a window, whether you've got passive house or not. So you've always got to have that flexibility within there. We're moving more towards passive house design just to control ventilation and energy. So I think you get better control probably with the passive house approach.
Fantastic. Great. Nicola, can I please invite you to share with us the collaborative framework case study from the Edinburgh Homes Demonstrator?
Yeah, great, thank you. So my name is Nicola Jackson and I'm a technical manager at Robertson Timber Engineering. My background's as an architect and I've got a lot of experience in the delivery of housing using modern methods of construction. Currently, I'm the chair of a group called Offsite Solutions Scotland, and I'm also a board member of the Edinburgh Homes Demonstrator Project, which is a project looking at a new model for the delivery of affordable homes using offsite construction. And there's a lot of parallels there with what Louise was talking about with the IPI model. So first, I just want to introduce the company that I work for. So I work for Robertson Timber Engineering, and that's part of the larger Robertson Group. Robertson are one of the largest family-owned construction infrastructure and support service businesses in the UK. And we've got offices across Scotland and down into the north of England. And we've also got a production facility up in Elgin in the north, which is where I'm based. So in that production facility, we're manufacturing closed and open panel timber frame components within a factory environment. And the two main things I wanted to talk about were collaborative work within Offsite Solutions Scotland and also the work within the Edinburgh Homes Demonstrator Project. So Offsite Solutions Scotland are a group of offsite manufacturing companies within Scotland. There's currently 7 different companies within the group, and we're located across Scotland, and we've got associates that we work with, including the Construction Scotland Innovation Centre, Edinburgh Napier University, Highlands and Islands Enterprise and Scottish Enterprise. And collectively we're working together. So rather than working in silos and trying to tackle some of the key industry issues, we're actually working together, and that's not common practice in our industry, but we've been doing that successfully over the last 5 years now. So within Offsite Solutions Scotland, we've been working to drive the greater adoption of offsite construction. We've been doing that by sharing best practice, and we hold regular meetings and workshops together. We've carried out joint research and development projects, and also joint innovation projects as well. And we've identified some of the needs for future skills development around the use of modern methods of construction. And a key project that stemmed from our work in Offsite Solutions Scotland is the Edinburgh Homes Demonstrator Project. And in this project, we're looking at developing a new model for the design, procurement and delivery of new affordable net zero homes in Scotland. And some of the partners that are involved in the project are listed here. So the City of Edinburgh Council, Edinburgh Napier University, the Construction Scotland Innovation Centre and Scottish Futures Trust in connection with the Scottish Government. So we're working on tackling the challenges that are set out here to deliver affordable homes in Scotland that meet future net zero emissions targets. And we want to deliver the level of quality that is expected and address the performance gap in the delivery of homes. We want to increase productivity in construction by doing more off-site and allow for workforce diversification through doing things in a factory environment and using digital technologies, which will hopefully open things up to a more diverse workforce. So the work, as well as through Offsite Solutions Scotland, the work also stemmed from some research that was carried out with Edinburgh Napier University, looking at the greater use of off-site construction for the delivery of affordable housing in Scotland. And through this research, there are a series of key things that we wanted to deliver through the Edinburgh Homes Demonstrator Project to tackle and look at changing the traditional method that's used to deliver housing through designing, procuring, and then building homes. So we're looking at a collaborative procurement model. And there's kind of 4 key work streams that are mapped out here. So in the collaborative procurement work stream, we're analysing other existing frameworks and procurement models that have been used to incentivise the use of off-site construction. Work package 2 is looking at delivering a standardised off-site build system with the aim to deliver standardised components, increase efficiency and quality control in the delivery of these standardised repeated parts. We're in the third work package, we're looking at aggregating demand and having a future pipeline of work that will specify the use of off-site construction, and it will have set pre-manufactured value targets to encourage the greater use of off-site construction. We're also going to be looking at whole life costings, and this includes looking at the performance of the buildings in use and assessing the efficiency of the building fabric and the net zero emission heating systems that are installed. And this data is going to be used to inform net zero emission heating standards and targets in Scotland. So the proposals that have been set on the Edinburgh Homes Demonstrator project are being tested and developed through a series of pilot projects currently in the southeast of Scotland. Pilot 1 is already in progress, and we're involved in developing pilot 2, which is looking to optimise the standard house types and build systems that have been developed on a live site. Beyond that, there'll be a further pilot, which is where we'll be testing and developing the collaborative procurement model. So what we're hoping this project will lead to is hoping to support the mainstreaming and use of off-site construction for the delivery of affordable homes in Scotland.
Cool. Great, thank you so much, Nicola. That's excellent, and I think really helpful again to see that kind of real life example as we go through. So we are ahead of time, which is brilliant. If there's any further questions, I'm just again flicking through the chat. I got confused there by Tabitha resharing the chat from earlier. Yeah, if there are any questions, please drop them into the chat. As I said before, Tabitha will be staying on. So if you've got any queries directly to Timber Development UK about the competition, about how it's working, about any of the other sessions. Just a reminder that this webinar series is running every Tuesday and Thursday for the next few weeks, so throughout the competition. Coming up on Tuesday, the title, the next webinar is 21st Century Timber, Properties and Engineered Products. And then following Thursday is on Timber Connections for System Performance. The Eventbrite links are now available on TD UK's Eventbrite page. Again, you'll find them by looking on our Twitter and various websites and so on. So looking forward to seeing you joining us again next week. And before we close, if there's no more questions, I just want to say an absolutely massive thank you to George and Carol, Louise and Nicola, and of course Alex, who couldn't be with us but has obviously prepared really hard. So thank you so much for giving up your time and your evening to join us and students and be part of the Timber Development UK 2022 Southside Hereford competition. It's fantastic.
Yep, thanks for having us. Cheers for that.
Yeah, thank you very much. Enjoyed that.
Thank you.